Now that you know the principles of functional programming, in this section we will focus on the programming language of our choice, JavaScript. JavaScript is continuously evolving. Originally it was used as a toy language to enrich the web with some animations. With the addition of ES5 and ES6, it is now easier to write programs in functional style than ever before. Although I still encourage you to use the abstraction of some functional programming libraries, it is worth learning the fundamentals in vanilla JavaScript. In this first video, we will focus on functional programming, introducing the relevant elements of ES6. Then, we will learn about different types of cloning in depth. The third video introduces you to the principles of context binding. After introducing method chaining, we will conclude this section with function sequencing so that you can start writing elegant code in JavaScript in pure functional style, creating small, concise building blocks. I will use examples to introduce the elements of ES6 so that you can see them in action. If you know the ins and outs of ES6, feel free to skip this video and return to it once you get stuck with the language construct in a future video. In this video, you will learn about creating block-scoped variables and strict mode. After getting to know primitive and composite types, you will find out about a convenient way of specifying object keys and values, the object shorthand notation. Talking about convenient ways, template literals will make it easy for you to embed JavaScript expressions in strings. A major simplification in functional ES6 is arrow functions. Arrow functions make it reading and interpreting functional concepts a lot easier. Believe me, I have opened a lot of functional programming books and courses in ES5, and it was a nightmare to interpret code examples compared to the arrow function syntax. Some other ES6 tools such as destructuring, spread operator, and rest parameters conclude this video. If you didn't know ES6 before, this section will give you many aha moments. Oh, by the way, this is not a complete summary of all features of ES6. If you want a brief, concise summary of ES6 and beyond, visit this link and use this GitHub repository as a reference for ES6. In the interactive version, you can even play around with the code examples. In functional programming, we don't use the var keyword to declare variables. As we will deal with immutable data structures, we will use constants. Whenever you write JavaScript code, I recommend using strict mode. In ES5, your task was to wrap your code in a self-executed function and start the function body with use strict. If you declare a variable without the var keyword, an error is thrown in strict mode. Without strict mode, you can get away with declaring global variables. Even though strict mode restricts you, these restrictions are beneficial. Although we won't really use the var keyword in the future, it's worth noting that it's function scoped. Launch will be available inside the function. From ES6 onwards, you can use let and const to declare block-scoped variables and constants. Although we can keep the self-invoking function to group our namespaces, we don't need it anymore. We can get away with a block. In this example, our launch becomes a block-scoped constant. Assigning a new value to our constant throws an error even without strict mode. In the rest of this course, we will stick to using constants except when we make a simplification or a concept requiring a variable is illustrated. Data types in JavaScript can be primitive or composite. In ES6, we have access to the following data types: strings, numbers, which can be both integers and floating points, and booleans. For completeness, we have to mention the undefined, null, and symbol primitive types. We won't encounter symbols in this volume. We will use null to explicitly indicate the absence of a value, and you will also find undefined, for instance, when indexing out of an array. Talking about arrays, we will also use composite data types in JavaScript: arrays, objects, and functions. Technically, arrays are objects. In ES6, you can use the isArray method to check if your object is an array. One important note about array and object constants is that they don't offer immutability by definition. Although reassigning the value of our constant throws an error, we are free to change any elements inside our array or object. If you want true immutability, you can use a data structure library like Immutable.js or build your own implementation by using the writable property of attributes. In this example, we ensure that the fries property of fridge cannot be edited. We are still free to add more properties to the fridge. In fact, we can even modify this property. We can prevent manipulating our object using object.freeze. Not a bad command to freeze a fridge. After freezing an object, we cannot add or remove properties of the object and cannot change their values. Once more, this syntax may become a bit too complex and you may have to write your own utility library to provide immutability. For this reason, we will explore Immutable.js in Volume 3. Objects have a shorthand notation in ES6. If the key name is the same as the variable storing the value, we can make the syntax shorter by omitting the colon and the value. Furthermore, we can also add methods to objects using the concise method syntax. You saw this syntax in the object-oriented code of the very first example of this course. Yes, the concise method syntax is available in objects as well as in classes. Oh, and by the way, when it comes to strings, we can now use template literals in ES6. A template literal can span multiple lines, and you can also place JavaScript expressions inside the literal. Functions are first-class values in JavaScript. In ES6, fat arrows were introduced. In this example, the arrow function add1 transforms its input num into a return value num+1. If we have multiple input arguments, we have to use parentheses to group the input arguments. We can use rest parameters in ES6 to indicate a variable number of arguments passed to a function. We have to keep the parentheses as ... num is nothing else but a comma-separated argument list. These arguments are accessible in the num array. The rest parameter has to be the last parameter of the function, and there can only be one rest parameter. We will now process the num array using reduce, and we will use a callback that adds an accumulator value and the upcoming element in the array. If we want to add 5 arguments 1, 2, 3, 4, 5, the result is 15. Destructuring is another operation that comes handy in ES6, as we can disassemble data structures and we can often shorten our code. In this example, we declare 2 new constants, head and tail. We place the first element of the array in head and the rest in the tail array. In this destructuring expression, tail is a rest parameter, consuming all remaining elements of the array. A rest parameter on the left-hand side of a destructuring assignment has to be the last element of the array. In destructuring, we create a composite data structure on the right-hand side. We equate this data structure with an expression containing constant names. We can throw away some segments of our data structure without naming them with variable names. We only have to provide the proper number of commas. Destructuring also works in function arguments. The getTail function accepts an array argument, destructures it in the argument list, and returns the tail of the array. The 3 dots may also symbolize spread operators. For instance, we can formulate an array by enumerating the elements of the tail array twice. The 3 dots transform its postfix operand into comma-separated values. This transformation is called spreading, and the operator is called the spread operator. Unlike rest parameters, you can use as many spread operators in an array as you want, in any position you want. The spread operator can also be used in function calls. When calling a function, you can assemble its argument list using the spread operator. When defining the argument list of a function, we use rest parameters to define how arguments of the function call are consumed. This video was a brief, fast-paced summary on some useful functional language constructs of ES6. We will introduce some more ES6 constructs later, just before we start using them. As a summary, let's play an association game. Write down some example ES6 code illustrating the following concepts one by one. pause the video whenever a new concept shows up. Block scope and constants. Primitive types. Objects and arrays. Object shorthand notation. Concise method syntax. Template literals. Functions, arrow functions. Destructuring. Spread operator. REST parameters. These language constructs will be an integral part of the remaining of Volume 1. If you want to learn more about ES6, access the summary by visiting this URL. As I said, our goal was not to give you a full overview on ES6. This video was included for the purpose of getting you started with the new editions of JavaScript from a functional programming perspective. Other ES6 constructs such as iterators, generators, promises, and ES 2017 constructs such as async await will be introduced later.